okay. Here, I'll give you the sticker, and then I'll get out of the speed. Yep. Good to see you. Go on, Stuart. Here. Okay, and so after we're done with all the presentations, I encourage you to ask whatever questions you want to the speakers. Watch them, you know, memorize their faces, find them. All right. Let's take this up here as a crutch.
Is this on? Everyone hear me okay?
That'll work.
Beautiful. All right. I'm going to show you all my slides in reverse. Sorry about that. All right. Howdy. My name's Ben. On the Eventbrite page for this event, it said that I'm a founder of something called Elk, which was an open source social networking system. That is true, but I lead up tech for something called Latitude, which is we're a cloud provider for video professionals. We let people, particularly TV stations actually, send video fast through the internet rather than using a satellite or a microwave truck, and then manage it privately in the cloud. And a lot of what I'm going to talk about is kind of born out of some of those experiences, but also from Elk and some of the perspectives from that. So, true story, I was out at a bar the other night with an Erlang developer, and we were talking, you know, conversation moved on to personal clouds, as it does, because I think they're important. And he said to me, no, why would I want to control my personal data? What a pain in the ass, which I thought was interesting coming from an Erlang developer. And he went on to say, no one wants to control their data. It's actually something that people don't want to do. If you look at the billion Facebook users, or if you look at all the people on Flickr, or the people on Google Drive, Dropbox, what they'd actually rather to do is sort of set it and forget it. And actually, his argument to me was that really, this kind of thing is often sold on ideology, and ideology is not a great way to sell software, except for people who are already aligned. What you need to do is draw a line between that ideology and actually something that directly benefits them, you know, makes them, improves their lives in a real measurable way. And I think one of the ways, one of the places where that's true is actually in the very impersonal clouds, in big businesses, in places like Torchwood here. And we, you know, we deal with a lot of very large enterprises, and what they say to us is actually, you know what, no, we don't want to deal with a hosted cloud. What we want to deal with is something that we control, that is on our own infrastructure, that we control the parameters of, which actually in many ways are, you know, that's the domain of the personal cloud. That's what we've been talking about at these meetups. And businesses need to. They've got ethical reasons to keep hold of their data. They've got financial obligations to their shareholders and other stakeholders. There's all kinds of things that they need to do. But businesses don't have finite walls. They're not bubbles unto themselves. And I think, you know, one of the things that we've discussed, one of the things that's integral to the definition of a personal cloud is ownership, right? And privacy is a crucial part of ownership, choosing who exactly can see your data, who can, you know, I keep, let's say, a file on my personal cloud, I get to choose exactly who can see it. And my data doesn't have to be files, it could be my name. Who gets to see my legal name? I get to decide, right, who is control of it. You know, privacy is a serious, is an integral part of ownership. But the flip side of that is that sharing is also a crucial part of privacy. And I think it's worth saying at this point that this is as well, this little 5-minute talk is a response to something that someone said last time, which was that personal clouds shouldn't be a social network. And I actually think that social is where a lot of the power in a personal cloud actually lies. Businesses, and I deal with media businesses, so I'll give you some context for this. They need to be able to invite me into their clouds to collaborate on their resources. So television businesses have networks of freelancers who are out in the field recording, you know, television journalism, recording other video, and they need to be able to send it back into these enterprise clouds. And they need to do it in a way, actually, that doesn't allow necessarily these individuals to be let into their corporate networks. They don't need to have to work, they don't want to have to worry about assigning an ID, they don't need to worry about assigning network privileges or the bureaucracy in a very large organization that is associated with that. They actually want to be able to use a cloud as a DMZ where they can say, right, this bucket and this bucket only is available to these 4 people because they need to send us stuff which we need. And the flip side of that is I need to be able to invite entities into my cloud to collaborate on my resources. I need, if I'm an individual actor and I'm working on something important, I need to actually be able to share a resource that is sitting in my cloud and let some other people come into it and work on it with me. The example for me is open source software, being able to open up a code base, let people come in, and again, only have access to that one piece, not necessarily have a username that makes sense, across the whole personal cloud domain. Now the question with all of that is, can we make this easy? Because there's already people working on these things. There's federated social networks. There's individual personal cloud projects. There's all kinds of networking standards that are happening out in the world. But the fact of the matter is, to go back to the original slide, people aren't going to use it because it's a pain in the ass. People don't actually want to manage their stuff. There's benefits, there's business benefits to actually having these self-controlled clouds and having your own cloud that interacts with an enterprise cloud. But it's hard. And I think the final part is that choice is a crucial part of ownership. One of the things I was going to talk about was how actually mobile phones are the obvious analogy for a personal cloud, something that's connected the whole time. You can install applications from a store. You don't have to think about it. It actually works almost like a version control system a lot of the time. And maybe some people want that, but I think you need to be able to, whether you're using a desktop computer, whether you're using something that is easy to use and maybe comes with your router and lives at home, whether you're using an enterprise set of rack servers, or whether you are using the managed cloud, you need to be able to choose whatever you want that makes sense to you. And all of these things, and here's where Google Docs falls down, need to talk to each other. They need to be able to interact. You need to be able to share resources. You need to be able to share between them. Because ultimately, if we don't include sharing and we don't include social in the personal cloud, it's just going to be a series of silos in themselves, ever smaller silos, rather than actually the one continuous cloud that we need to be building. And that's what I wanted to put forward. Thanks.
Cool. Questions? I have one. So can I build a personal cloud from Elk?
No. And you know what? I mean, I'm quietly in the process of thinking about what it would take to build a social networking platform in 2013 rather than 2003, which is where Elk comes from, really. Yep. And because I think one of the things that you need to have is this awareness that actually, when you're building anything, whether it's a cloud or a community or a space on the web, you have to understand that it's fully connected, to the internet, and I think you have to build that into the structure from day one. So that is something I want to do.
Cool. So any hackers here want to join up with him? One thing we haven't done actually, and I'd really like to see that happen, is there's a lot of techie people in the audience, and I'm sure as all techie people, we have way more things that we could be working on than we possibly have time for. But one thing I would love to see is if some of us hooked up and said, let's build something. Yeah. And I think that would be one of the goals of these meetings, at least from where I come from.
So I'm going to cheat and ask a question related to what I'm going to say in one of the upcoming talks. Why do you believe that we can get people to demand their privacy?
I don't. I absolutely don't believe that we can get people to demand their privacy. What I think we can do is build better software that does things that the managed clouds actually can't do. There's more individually tailored, there's more configurable. I think there are some people, my dad comes from the 60s, he was part of the whole kind of Berkeley movement. He doesn't want to have Google ID, he doesn't want to have any of this, he thinks they're spying on him the whole time. I think that's not true of most people. So I think what you have to do is build better software that has,
You're not spying on most people all the time?
I didn't say that.
I was parsing your sentence.
One more question?
Alessandro Acquesti from Carnegie Mellon recently published a study on the fact that adding privacy controls to the user interface and to the end user's ability increases what they share.
Yep.
But the reality is that the problem for the end user hasn't changed. The information, once it's released, is subject to copying and all of the things that happen, whether it's connected social network or whether it's a closed personal cloud sending it out to another place. Once it hits the other place, you've got no more protection of what happens there
So
once it's out.
I think there's two problems there. One is partially solved by this idea of letting people into your cloud and not always pushing stuff out, not always sharing, but letting people in and opening those permissions selectively. The other problem is much harder, which is how do you stop people copying things on the internet? And I have no answers for that whatsoever.
I mean, short of a DRM at the data level,
Which wouldn't work.
which will never happen,
Yeah.
but I mean, short of a DRM at the data level, you can never control what happens once it's out. And that's the essential problem to all of these things. We haven't figured that out, and that's ultimately what people care about.
Okay, that's fair.
Okay, thank you. So now I get to switch hats and tell you about a little project that I did. I have one there. So I have a company that does something around this, but I don't want to talk about this. I want to talk about a little hobby project that I did over the Christmas vacation, basically. It turns out my pool has a personal cloud, and I want to tell you about that personal cloud. When I built it, I didn't know it was going to be a personal cloud, but that's what it turned out to be. Here's my pool. It is in use occasionally. To run the pool, I need to do two things. I need to filter the water regularly, and I need to run this little sweeper here. We call it a dragon because there's a long tail and it squirts all over the place. And traditionally, the way this has worked is this way. This is how we got it when we bought the house. So there's these two electromechanical timers in here, and they are supposed to run these two pumps, on some schedule. And you can see that there's some business rules that come with it that the previous owners wrote on the box. And so, anyway, that's what we had. And the problem was that one of those timers broke. Well, it's an ancient timer, there's no replacement parts, so it didn't fit into the box, and I figured, I don't really like these things in the first place, because if you look like inside, it looks very awful. There's these little jumpers that have to make that switch the contacts. They're never, the timers are never at the same time, as you can see right here. The jumpers fall off. You don't know where this thing ran. You pull this green, you have no idea why. It didn't run enough, all of these things. So I figured, okay, this is a project. There used to be an electrical engineer. Let's see what we can do about this. So here's the new version of it. You can see it's become simpler. There's no buttons, and I'll show you what's in it in just a second. The user interface looks like this. That's on my home Wi-Fi network. I can say pool. Now, what runs there is a very simple piece of PHP that I hacked together that talks by Wi-Fi to what's behind this silvery color here. And it has a bunch of functions, including, you can turn on and off the pumps. It has been very, very successful. It has been so successful, the first feature I had to add was access control. Because my kiddo would go on and off and on and off and on. Yeah, this is sort of interesting itself. So if you look like what's in it, we actually have more wires. But let me outline what this is. So there's this box that I put in here. This over here is a power supply of 5 and 12 volts here. This down here is a Raspberry Pi. Who does not know what a Raspberry Pi is? Oh, some people. A Raspberry Pi is this little single board computer that they came up with in the UK. $35, you get a fully functional Linux box, including graphics and Ethernet and everything. And so you plug in, it has USB here, it has HDMI, which I'm not using, and it has some I/O pins, which is what I'm using here. So these I/O pins drive a few transistors, which drive these two relays that you see here, which switch 240 volts for the pumps that are really rather big consumers. And so that's what I put in here. It doesn't actually have a user interface because it's all Wi-Fi. Here's another user interface part of, it's electronic now. It tells me when this thing actually ran. Which you can see the different days, and then these are the time of day when it ran, and there's the two pumps and how long they ran. Here the pool turned dirty, so I ran it extra in the afternoon. So this is just a cron job that runs there once a day. So here's the parts that I assemble. There's a Raspberry Pi, $35, fully fledged computers, a USB dongle for Wi-Fi, an SD card as a hard drive, power supply, 2 relays, a custom panel, a bunch of pots and ends. Cost me about $160 in parts. This thing could run MySQL if you wanted to. It runs Apache for sure. So it's fully fledged computer. And what I'm running on here is Raspbian, which is a version of Linux for the Raspberry Pi, Apache PHP, and a bunch of PHP that I hacked together that you can find on GitHub if you're so inclined. Here's what I learned. This is really fun. I encourage you to do projects like this. This is really cool. But I'm also very rusty. I used to do these kinds of things when I was a teenager, and then the more I learned about it, for some reason, the less I did it. But anyway, I want more sensors. I want this pool not just to tell me when the pumps ran. I want it to tell me what temperature it has. I want it to tell me how dirty it is. I want it to tell me what the status of the filter is, because I have to backwash it every so many months when it is all full. I want more integration with weather forecast. If it's getting hot, I want the pump to run longer because the algae grow faster. I wanted to hook it into PG&E dynamic pricing. These pumps are pretty big; they take a lot of electricity. So I'd like to, turn it into the right tariff. I want a lot more intelligence. I want this thing to figure out what the weather is going to be and whether someone's going to use it, and then run the pumps at the right time, right? And then I have found myself, and you will not believe this, I have found myself sitting in the living room with the iPad and first typing in pool into the browser bar to see what my pool did this day. And I started to type in thermostat, and I realized my thermostat wasn't accessible that way. Speak about a white change. And I want a personal cloud for my thermostat, the house, for my irrigation, and for my front hall. Oh yeah, we can buy various things, yeah. So I'm just, where I come from, I don't have that yet. I want one for my front hall, so it show me who is there when the door was opened last time. I want one for my pantry that tells me what's in it. Well, I kind of have that. And so I don't know how many of those projects I have time to do, but it would be really cool to do. And here are some remaining problems. And many of them have to do with credentials. It turns out, if I get hit by a bus, we're out of luck.
You just need HTTP//bus.
Yeah, right. So credentials are a huge issue. Okay, so I can set my an SSH account up on that thing for my wife, who happens to be technical, so she could probably do something about it. But it's a problem. If we have these personal clouds and these things all over the place, how do they ever get administered, and what's the security structure here? I'd like to have single sign-on across all the devices in my house from all the vendors. How do I get that? I don't have the slide idea. Authorization is a big one. Right now, I have just, for those of you who know Apache, I just have a little HTAuth file there that says, these are the people that get to log in because it was the cheapest and fastest thing to do. But what I really want to have is some kind of authorization management across my house. I don't have access for outside the house. This is just local on the Wi-Fi. And there's a big issue about software upgrades and monitoring. And this is a nice hobby project, but if you really look at it, it is really complicated to productize this. And there's a lot of people, I'm sure, who would like to have a pool control like this. It has changed the way I interact with my pool, but I have no idea how I would turn this into a product if I were in the business to try to do that, which I'm not, but it is not obvious how to do that. That's all I have. So ask me something. Yes?
So why is this a personal cloud?
Well, for me, it's a personal cloud is because that's the way I interact with the pool now. And it goes by way of the cyberspace as opposed to by way directly. And for me, if I wanted to interact with you, then you have a personal cloud. It's the same model. I can interact with you directly or through the personal cloud. And so I think of it as a personal cloud.
Okay.
Now, it's a very rudimentary one because it can only do a few things. It's just a few bits, basically, of information. And it could have a lot more, but I can see how it grows, and eventually it could encompass everything there is to know about my pool and every behavior that it has. Right?
There's a company called Lobby Flood that's coming to help look for that productization and deal with all different languages and protocols that across the center. So
I'm actually aware of them, and it would be cool to have them speak about it.
I'm
this is a good group to try something out with. It's not, there's no product announcements or anything like that.
Okay.
So you're saying you're not sure how to turn it into a product, but have you put any of the source out there? Have you put any of the source out there? Because I would love to hack on this.
Well, this is just a vision from PHP editors on GitHub.
Yeah.
Yes. But the difficulties are, so the code here has a table in it that says, you call it main pump, and it goes to pin number 3. Right? It's very difficult to productize this, because who else has a pin number 3 in the device? So that what exactly is the piece of hardware that you sell with this that will have that pin number 3?
But could you put schematics for the Raspberry Pi sort of in the so you can say, okay, attach it to this pin and go this way?
I think you probably could. That is a different version of of rapid application development, I think, than we're used to. But sure. I mean, I actually had somebody who took that code and hooked up a thermometer for his pool and came up with something. So hopefully these kind of things, these kind of projects will occur. So I think Brad is next. Well, you set up maybe
it's on your computer, so.
Okay. This one. This one.
Take the microphone.
Switch up here that may or may not be on.
It has the offness to it. I must admit, when you said you had a personal cloud in your pool, usually that's when I turn on the filter. Sorry about that. All right, so I've actually been pushing the idea that we're now calling personal clouds for about 5 years, and nobody wanted to pay attention back in 2008, and I'm glad to see actually that people are more interested in it now. But the challenge that always sat in front of me was indeed how to get people to actually want to use this, to want to buy this, because these ideological, and some of the other speakers have sort of set this up, that the ideological principles aren't what make it happen. So the architecture I proposed back then was based on this philosophy of bringing the code to the data rather than sending your data up to the code. And I think that's a good way of summing, in many ways, what you want to do with personal cloud computing. And in particular, I was suggesting you'd have a piece of cloud resources that had some virtual machine on it, like the JVM. You'd go to websites, they would embed an iframe in the website. The iframe would be served by your system, wherever it was. That system would load classes that were written by the website to act on your data and display results back to you directly to your browser. They never saw the data, your browser saw it. Then you'd have publish, subscribe of feeds from friends and other parties and so on, so that you could do social networking, which I think is a very important thing. I think people want all their applications, almost all their applications, to be social, and if you can't meet those needs, you're not going to compete in the marketplace. And finally, the data can leave, but in this case now it's the default that the data stays. And if there's a real need for it to leave, it can, but that's the exception, and it has to happen. And then finally you need something I call forgetful brokers, which are third-party machines that can combine two people's data without revealing the secrets to either one, but promise to forget what happened after the fact so that you can again do some of the social applications. So that would be great if we could build that. The question is how to sell it, because I don't think you can sell it on privacy. If you try and make a business in privacy, as the joke goes, you'll make a small fortune, having started with a large fortune. They've done a lot of tests, and people just will not pay money for privacy until after they've seen a personal invasion. Then they'll pay. Some of the paranoid will, but it's hard to get them to do that. So what values can you sell? So I think control is an important value to sell. The idea that if data is now residing under computers under your control, and you have more control, not over your data, actually, but over what applications you can install and what you can do with the data, which you had on your personal computer, and you lost when you decided to delegate that to Facebook or Google or any of the other companies. And you don't actually want that control for yourself. What you're interested in is giving the ability to delegate that control to clever, innovative third parties no one's ever thought of yet. And that's what doesn't happen in controlled ecosystems. In controlled ecosystems, there's a beautiful, consistent vision created by one great visionary, whether it's Steve Jobs or anyone else. And everyone loves the beautiful vision and buys into it. But that vision eventually doesn't think of things that the chaos at the bottom does think of. And those things rise up. You want the ability to let open source developers do things for you that you can run. that control is the essential thing. That is freedom. So that gives you innovation. Two other values you actually can get from a personal cloud architecture are speed and innovation. So I cannot make Facebook faster by buying a faster computer. Right? And that is a failing compared to the old cloud, where I could make the software I ran run better and faster by improving my equipment or improving my bandwidth. Improving my bandwidth will make Facebook run a little faster, but otherwise it's under their control how much resources I'm going to get. And this provides an interesting scalability. Most people like the big cloud because it provides them what they think of as scalability. But it's linear scalability, which to us nerds is not scalability at all. You have 10 times the users, you've got to buy 10 times the resources from Amazon. Skype is able to make a phone company for 1 billion people without having very many servers at all, basically, just a couple to do the keys. The scalability came because each individual piece of computing power was owned by a radio. And that's a pretty powerful value, actually. It means you can build new things without getting VCs to fund the large cloud resources you have to buy. So here's the mission, though. You've got to be better than Facebook in every way, or at least as good as. It's got to be as easy to sign up for as Facebook is. And right now, people have already done the sign up for Facebook, which makes it even more challenging. It's got to be as easy to use as Facebook means just going to a web page. And it's got to be as free as Facebook, which is pretty hard. It's got to be as profitable for developers to work with it as Facebook is, and as easy for them, and as accessible, more accessible, ideally, to those developers. And then also run as reliably. This is a large set of challenges to do in a distributed personal cloud system. Getting the ease of use means no code to install, no hardware to install, easy to bring your friends in, easy to bring your vendors in. How are we doing on the
30
time?
seconds.
Oh, just a few seconds more. So how to make it free? Well, running your own server is only for us nerds. I have a dream that your ISP might provide this to you, just like the way it provides you email, but that doesn't happen yet. We could try and bring ourselves to there. It's got to be always on and mirrored and local, all those things people love about other clouds. You're right, I am out of time. And so the one way I propose to do this, just to finish off, is to suggest an architecture of payment tokens. So you want to convince companies like Amazon Web Services, Google App Engine, and all that so on, to run people's clouds for them, or any provider they want to choose. And let the people who want to do websites provide a payment token with each web hit, which is just good for a few tenths of a cent worth of computing. And that token goes along. And so Amazon can get paid for running your personal cloud, but the VCs funding the new startup can be the ones actually paying the money. So you can build and if you want to run your own personal server, great, but that's for the nerds. For the rest of the world, it just looks exactly like it looks today. And that's my vision of a possible way to get people to pay this. So let's get some questions. It's one of the three things I think you can convince people, but not, as I said, not their own ability to control, because as the earlier speaker Ben said, people don't actually want the hassle of managing their data. But what they want is the fact that 1,000 flowers can bloom from a chaotic world of innovators to help them, and control lets you pick among those people.
What I would suggest is perhaps besides control, something of value that people have. Their personal data is worth money.
Yeah, I don't believe that. I don't think it's worth money, therefore they're not going to believe it since it's not true. Your personal data is highly valuable in aggregate, and there's lots of people who will trade data on millions of people and so on. But I don't know, I've seen this proposition 100 places. Oh, look, you can get paid some of the value people have in your data. The amount of money I've ever seen on the math is inconsequential. It's not going to make a change in my decision pattern.
I think that is an open discussion point.
No, but you're right. I'm not saying I have the last word on that.
Right. I playing moderator for a second. That is a discussion that we have seen over years and years. I think somebody has to prove that is actually true.
Yes.
And then it will be resolved.
So Brett, this issue of the third-party developers and this idea that the data stays and the code comes and runs there. Part of the value proposition for the service providers is the data and the metadata, the data about the data, right? And so if you think about Facebook, people complain about their information, but the reality is not really about theirs. It's the metadata they keep about what you're doing. So for them, there's externality values. In the model you're proposing, you're cutting off that, because now it's all residing within the user's ability to do that.
Yeah.
If the actors who are playing don't create the apps to run in this model because they lose out on that, how are you ever going to get this to be accepted? Users alone can't do it.
Yeah, so Facebook is this 800 million, now billion user gorilla, which everyone wants to compete with. And they can't compete with it on its own terms because there's a natural monopoly in social networking of sorts, and only someone as big as Google can even make a play at it right now. So I think that they would be willing to play this way because there might be enough users. Might be. We have to have a valid selling proposition that the users like. That someone says, here's a way I can be different from Facebook and in something they can never do. They can never give the users what I'm going to deliver, and it's an advantage for me, and that's what would bring developers in because they have no other choice. There is no other way for them to compete with these big players.
Okay. Next is the continued discussion outside when we're done with all speakers. Thank you. You have your own, right?
Sure.
Whatever.
There's a mic if you need it.
You can yell or use this microphone or use the little one.
I think I'll yell. So I'm Harlan Wood. I'm co-founder of an open source startup called Enlightened Structure. And that's just not okay. That was the sneak preview you weren't supposed to see. Enlightened Structure, we're interested in everything from the very low level to the very high level, and we're going to be talking about some very low level geeky material today, namely an architecture for a content addressable graph storage. And we're calling this base paradigm, which is a term coined by my friend Travis Wellman. Okay, so first of all, what is content addressable? Very quick review for the geeks or quick intro for anyone else. So SHA-1 is a common hashing algorithm which will take any piece of content and turn it into a unique, kind of unlikely to collide address. The larger the size of the hash, the less likely it is to collide. What we're doing here in this example is just switching the word dog with the word cog, and the point is just that we come up with massively different addresses. So suppose our application is receiving, in this case, JSON, subject, predicate, object, data. And in this case, we've got nested edges, if you will, where the subject is itself a subject, predicate, object triple. So Augustin thanks Harlan, and that thanks has the content, great programming session. This is, he actually said that, so I didn't make that up. So with content addressing, what we're going to do is we're going to take every one of these strings, the keys and the values, and turn them into a content address. So for the more, oh, I forgot, geek toys. For the geekier among you, we're using the SHA-384 algorithm here, and we're actually just representing the first 16 characters of the 96 character SHA-384. But the point is not that. The point is that the word subject has a unique address, and so we're actually making a file with only the word subject in it and naming it after the content address.
You think you're geeky with a purple lizard. Mine is ultraviolet. Look.
So this is hashing all of our content blobs, including our keys and including our values. Now we're going to go and hash our actual graph data as well, because what we want is a content addressable graph, the whole thing to be addressable through its content. So we're going to hash our edges and hash our graphs. Here we have a base paradigm style edge, which the comments here are a description in case you've forgotten the hashes. So the word subject, predicate, object are our keys, repeated here, the word subject, predicate, object. Augustin thanks Harlan, And this is where it gets a little more interesting, because this is our edge. The subject is the edge in the second one. And similarly, in this graph, where we're pulling these edges together, this is edge 1 and edge 2, edge 1 and edge 2. Did I get that right? Yes. Okay, So what's this all about anyway? Like, why are we talking about content addressing graphs and data and stuff? So this brings the potential for semantic interoperability between applications, and we're doing that by hashing human language, in this case English. If we go back here, we're looking at, so this is a very simplified example of a gratitude application, right? Where Augustine is thanking me, and suppose we have a whole ecosystem of gratitude applications or semantic currency applications. They can talk to each other, they can read and write each other's data in this format, in this kind of universal-ish graph format where everything is hashed, and the relationships are hashed as well as the data. It's kind of like a Git repository, again, for the geekier audience, that contains the entire internet, or at least the parts of it that we care about, which is the data in my personal cloud, or the data in your personal cloud. And we can conceptually rsync graphs and nodes between personal clouds. In the last one, we've got a kind of global unified distributed graph. And I'll flip back just to show that what I'm talking about with the key value store of nodes and edges. We already saw how the edges can be nested within other edges. And what I mean by the key value store is simply that all of our data comes in pairs, right? Key value, subject, predicate, or edge, hash. And the one last thing I'll close on, and this is hopefully the I get it moment for the hardcore, we're into bits and bytes. It's that these 6 items, that's really just a string of bytes. And so it's really just 6 strings of bytes concatenated together that are hashed into another string of bytes, that's the content address. And whether those bytes, because those bytes come in pairs, we can tell what's the key and what's the value, and right, so we can hash content and hash data in exactly the same ways. And that was a really deep dive in like 5.5 minutes. I'll take any questions. Sir?
So the JavaScript or JSON object is already associative array, a hash. Doesn't that give you the content addressability already? So why do you need to do explicit hashing?
Sure. Certainly, we could hash the JSON string, and it's interesting to hash canonical-ish forms of the JSON strings, where we sort by keys and take out the white space and stuff like that. That's useful. And why is it additionally useful to break it down into the constituent parts and to hash the subject, object, predicate? One reason is for indexability. Like, it could be very interesting to see who are all the people who have thanked me, who are all of the people who Augustine has thanked. So that's one answer. And another answer is because we're only storing one copy of anything that's content addressed. And so when we're storing me, the subject, we only ever store me once, whereas the JSON is going to be different every time, and so we're making a new copy every time. Other questions?
Quick one. Sure. Are there some examples where you want to reverse the hashing for an application? Because what the hashing makes it rather impossible to go back to the clear text.
That's right.
So is that a feature or a bug?
Well, great question. Certainly hashes are irreversible by definition, especially because they're often lossy. And is it a feature or a bug? It can be a feature for security, right? You can pass around the keys, the hashes to your data without revealing any of the content or character of the data. And it could be a bug if you lose your content and you just have your keys. But don't lose your content.
A quick one? Sure.
Key management is also an issue, right? Key management. How do you manage the keys? Where do you store the keys?
Sure. Similar to a source control, distributed source control repository, sort of store them in a directory of blobs named after the hashes.
So if you want to exchange information with somebody, how does that person get your keys unlocked?
Sure. So you could essentially, rsync your whole set of data to another personal cloud, or more interestingly, in the personal cloud context, just part of it. There's usually just part of your personal cloud that you're interested in sharing with a group or an individual or what have you.
Okay. We can follow up later. Next speaker, Augustine.
All right, thank you.
Thank you.
Can you hear me? Does it work?
Yep. Yes.
My name is Augustine Brawley. I'm an application developer, and I've been fascinated with personal cloud tech since I heard about it, or heard about it before I even knew it was called personal cloud. I built an application that kind of helped contribute to this whole area. It's called Grazie. And I'll show it to you today, but before I do that, let me explain to you about a little bit what it is. It's all about gratitude. It's a simple way to say thank you to the people in your life, but also to receive an acknowledgement, to get a you're welcome. That's pretty much it. But it's also a whole lot more than that, because it's a different kind of application. It's a distributed, unhosted web app. It's about making it so that no one single organization can own all the gratitude in the world. So that's the kind of like what it is. And let's get into looking at it real quick. So here's Grazie. It's live right now, grazie.org, but it's very prototype, and please don't tweet it just yet, but you can poke around with it if you like. So you hit create a Grazie, and then it asks you to connect to a Dropbox, which, since it's distributed, I don't store anybody's data. So the user would then click Dropbox, and they'd authenticate, and they'd say, yes, this application Grazie can access my Dropbox folder. And then since I've already done this before, I have a profile. So I'm going to send my other pseudonym, Great Prez, dude. Personal cloud. So very simple, you see that it created and then emailed. Now let's explain to you later how that works. Basically what it did was, see this little pop-up here? A file was created in my Dropbox folder, and an email was sent to this guy who's like Augustine number 2, and he'll get an email eventually when the emails get here. And he'll go to this, and he'll click the button in his email, and he'll go to Grazie, and he'll accept this document that will then be saved into his Dropbox folder. And at the end of this process, this dual handshake, both parties are going to have this document, this two-way agreement of gratitude and acceptance. And I won't have any of it. Grazie.org will not actually own any of this data. So